about classification of physics. There are classical physics and modern physics. In classical physics, there are mechanics, which studies motion, acoustics, which studies sound, thermodynamics, which studies heat, electromagnetism, which studies the electric fields, and optics, which studies light. And in modern physics, there are solid-state physics, elementary particle physics, relativity, atomic physics, nuclear physics, and quantum mechanics.
The unit system is a collection of units of measurement and modes. There are three more popular systems of measurement. The most popular is the system of units abbreviated SI by their first initials that includes meter, kilogram, and second. Or is the CGS that includes centimeter, gram, and second. And the other most popular unit system is the British that includes foot, pound, and second. Conversion units. And in the conversion units, we can see the equivalences that we use to transform one unit to another unit of other system. For example, if we have 2 meters, we have to use this equivalence to convert meters to centimeters. So we have 1, this is by 2, and we multiply it by 1. So we have 2 centimeters. If we have to convert these the centimeters to inches, we have to multiply by this equivalence. We use to know different units in different systems.
Addition of parallel vectors. If two vectors are parallel, it means they're going to the same direction or the exact opposite. If they're going to the same direction, it means we've just got to add up the two vectors to get the resultant vector. If they're going to the opposite direction, it means we've got to subtract one from the other to get the resultant vector. It doesn't matter if they're on the x-axis or the y-axis. Addition of perpendicular vectors. If two vectors are perpendicular, it means they're running on different axes, one on the x-axis and one on the y-axis. To add them up, we need to put them on a Cartesian plane, and put one in front of the other. It doesn't matter the order, we just need to put one at the end of the other. To add them up, we need to use the Pythagoras theorem, which is a squared plus b squared equals c squared, and we just need to do the whole process. To calculate a resultant vector with the analytic method, we are going to use this table over here that we're going to fill with the information given by the problem. To fill the other two parts of the table, we're going to use the magnitude times the cosine of the angle for both forces, and then the magnitude times the sine of the angle again for both forces. And then again we're going to use the Pythagorean theorem to get the resultant vector, and we're going to use the inverse tangent of y over x to get the angle, and that's how we use the analytic method.
Of speed and velocity is that the speed includes distance and velocity includes displacement. Distance is where the total movement of a person, for example, he moves 3 meters north and 4 meters east. It moves 7 meters. But in displacement, if a person moves 3 meters north and 4 meters east, the total displacement will be 5 meters because it's the final movement. And the speed is distance in time, and velocity is displacement in time. That's the principal difference between speed and velocity.
Uniform linear motion. In uniform linear motion, we studied the movement of a body with a constant velocity. For example, if a body moves 500 meters, in 5 seconds, it means that we divide 500 meters in 5 seconds, and it will give us that it has a velocity of 100 of meters per second. If a body moves 200 meters in with a velocity of 50 meters per second, it means that if we divide these two data, it will give us that it get a time of 4 seconds if in his movement. If we have that a body move with a constant velocity of 10 meters per second in a time of 10 seconds, it means that it will moves 100 of meters. In uniform accelerated motion, we have different formulas that will give us the information that we need to know what is the acceleration, movement, acceleration, velocity, distance, and final velocity of a body in movement. In accelerated motion, the body has a constant acceleration in the time. For example, if we have 4 meters per second to square, we have an acceleration. The rate of change of velocity per unit of time means acceleration. And if we have 4 meters per second to the square, the acceleration is for the velocity plus 4 meters per second every second. In acceleration is equal to final velocity less initial velocity over time. Final velocity is equal to initial velocity plus acceleration multiplied by time. Distance is equal to initial velocity plus acceleration multiplied by time to the square divided by 2. Final velocity to the square is equal to initial velocity to the square plus 2 times acceleration multiplied by distance. Distance is equal to initial velocity plus final velocity over 2 multiplied by time. Those are the formulas of uniform accelerated motion. Graphic analysis of accelerated uniform linear motion. As acceleration is constant in linear motion, we can see in a graphic that it keeps constant with the time, 4 meters per second to the square. Velocity is increasing every second, so we can see that if the acceleration is 4 meters per second to the square, we can see that the velocity gets increasing 4 meters per second every second. So in 3 seconds we are gonna see that velocity has 12 meters per second. In distance, as the velocity is increasing every second, we are moving a greater distance every second, so we can see that it has no linear vector, so it has a greater distance every second. Free fall. Free fall is like accelerated uniform linear motion, but its difference, its principal difference is that acceleration in free fall is gravity, and instead using x-axis we use y-axis. If we replace all the formulas using gravity instead acceleration and y-axis instead x-axis, we got these formulas. For example, acceleration is equal to final velocity multiplied by initial velocity over time. It is equal to gravity. Gravity is equal to final velocity over time. The other formulas that we have is that final velocity is equal gravity over multiplied by time, and y-axis is equal to gravity multiplied by time to the square over 2. Final velocity is equal to the square final velocity to the square is equal to root of 2 times gravity over multiplied by y-axis. Y-axis is equal to final velocity over 2 multiplied by time. For example, if we have a ball that gets 2 seconds on crash and stop, we have that gravity is equal to 9.8.8. Oh, and if we have 2 time, we can get final velocity and y-axis. Gravity multiplied by time, 9.8 2 times is equal to final velocity. So final velocity is equal to 19.6. So get the final velocity. Y-axis, we can get it by multiplying gravity per time to the square over 2. If we do that, we get that is 9.8 to multiply by 2 to the square, that is 4, over 2 is equal to 19.6 meters. So we have 19.6 meters. So this is how we calculate a problem of free fall. Vertical throw. In vertical throw is similar to free fall with the difference that it has an initial velocity that gets reduced with the gravity. Gravity in this case is a negative acceleration. If we gonna get the data, we can separate the vectors in the vector that gets upside and the vector that gets down. For example, in this in these separate vectors, we can see that the initial velocity of this is 39.2 meters per second with a gravity with a negative gravity of 9.8 meters per second to the square. If we have this data, we can know that if we divide the initial velocity over the gravity, we can get that the time is 4 seconds. So in the first vector we have the time that gets of going upside is 4 seconds. If we analyze the vector that gets downside, we can see that the initial velocity is 0 meters per second and the final velocity is 39.2 meters per second to this, meters per second with a gravity of 9.8 negative. So we have a negative final velocity and a negative gravity. If we divide that, we get 4 seconds. In the division of the upside vector, we can notice that time is not negative, so we have 4 seconds. If we get the 4 seconds that gets in going inside upside and going downside, we have that total time is 8 seconds. The gravity will be negative 9.8 meters per second to the square. Initial velocity of the first vector will be 39.2 meters per second and the final velocity will be the final velocity of the second vector, that will be 39.2 meters per second to in negative. So in y-axis we can get it multiplying the gravity to the by the time to the square divided by 2. If we do that, we can get that the y-axis, well, the height of the vector will be 78.4 meters.
The horizontal throw is when an object from a higher point gets thrown in a certain velocity. In this case, we have an object from 29.4 meters of height. It's thrown with a velocity of 10 meters per second. Now, in a horizontal throw, the velocity is always going to be constant, and the acceleration is always going to be 9.8 meters per second squared, because that's the acceleration of gravity. Now, in the parabolic throw is really very related with the horizontal throw, but now we've got the other side, and it's actually quite the same. We got the constant velocity and the upwards velocity, which is represented by y. Now, in the parabolic throw is actually quite related with the horizontal throw. The only difference is that we now have the other side which goes upwards instead of downwards. Now, if we know that this velocity of the beginning is 10 meters per second, and we know that it's going to be constant, it is going to be actually the same on every corner. And now in this side, we know that the upwards velocity, which is this one given by the problem, is going to be, we're going to subtract 9 meters per second instead of adding. So that's actually the only difference between those. In the highest point that it reaches from the object, we know that it's going to be 0, the y velocity, and then the velocity goes negative, as we can see right here. As we subtract this 9.8 meters, we're going to have